Alrighty, y'all, welcome back to another video, and in this one we are going to be covering Remix. So to see this tool, go to remix.ethereum.org, and alright, so once you go there, you're going to be greeted with a screen that looks like this. So first of all, what is Remix? So Remix is an in-browser IDE for writing smart contracts. So if you just want to jump into writing smart contracts, play around with some things, but you don't want to download and install some, beefy, bulky piece of software, then this is the tool that you can use. Now, with that said, I'm not going to recommend this tool for developing production grade dApps. This is more, you can think of it almost like a playground. It's a useful tool whenever you're working on simple smart contracts or smaller projects. But like I said, probably wouldn't want to stick with it for production grade dApps. For that type of environment, we're actually going to be getting into that in the next video. But for now, I just wanted to go over this tool. It's a very handy tool, so let's go ahead and jump right into it. Now, on the left right here, you're going to notice workspaces. Now, you can think of a workspace essentially as a project in Remix. So actually, we can go ahead and create a new workspace now. And whenever we do, we can see that it pops up right here is the new item in the menu. And this menu right here is just how you switch between your workspaces. Pretty simple. So a new workspace is going to come with a very basic project structure, and that includes your contracts directory. And inside here are your Solidity contracts, and we're going to be writing one of these in just a few minutes. Under that, you have your scripts. These are your JavaScript files. And then under that, you have your tests. And this test right here is testing one of the Solidity contracts. And last but not least, you have a README, which is essentially just a README overview description for the project. Now, in order to best understand these other sections of this IDE, it's probably useful if we do have a simple Solidity contract. So let's go ahead and create one right now. So to create one, if you just click on this contracts directory and you right click, you can click new file. And I'm just going to name this bucky.sol. And the name doesn't really matter. Well, it does in a lot of cases, but for this example, it doesn't really matter. .sol just means that it's a Solidity file. In other words, smart contract. You can think of it like that. And all right, let me actually boost this up so you can see. And if you click this button on the left, you can actually just toggle this left menu. All right, so we are finally ready to start writing our first smart contract. Where do we begin? So the very first line in your smart contract, actually, let me do you hear that noise? It's like marbles running down my wall. I don't know. That's a weird noise. Anyways, okay. SPDX, and then you want license identifier MIT. Okay. So the first line here is actually a comment. It's SPDX license identifier MIT. What does this mean? This is just an open standard stating that this source code is MIT licensed. And this is actually recommended to include in all of your Solidity files. And right under this, let's go ahead and write pragma solidity 0.8.7. Okay, so what does pragma solidity greater or equal to 0.8.7 mean? So this is just indicating what version of Solidity we're using. And by that, I mean the Solidity language, and not only the language itself, but the related compiler to compile this source code down into bytecode changes over time. And that's just because, well, really with any programming language, as new features are introduced and, maybe syntax changes, that the language naturally changes. So this is really just saying that we're going to be using this version of Solidity. So we need to make sure when we compile this down that the compiler supports this version of Solidity as well. So now let's hop into the good stuff, and that is actually writing our contract. So to begin a smart contract, you begin with the name contract, and then you can actually name it really anything you want. Some limitations, of course, no weird characters or anything like that. But the name, of course, should be descriptive of what the contract is. And just as a quick overview in terms of kind of porting this over to some programming concepts, when you think of a contract in Solidity, you can think of it similar to a class in an object-oriented language. So this contract, similar to a class, is going to contain variables and functions, so on and so forth. Now, whenever we deploy this contract to the network, what you can think of that process as is creating an instance of this class. So essentially, we are going to be creating an instance of Bucky and pushing it up to the Ethereum network, and that is essentially going to be our smart contract. So if all of that's a little hazy, don't worry about it right now. It's going to make sense whenever we actually deploy it and interact with it a few times. It's going to click pretty clearly what's going on. So now let's go ahead and talk about what the smart contract is going to do. So we just want to stick with a bare bones, simple example. So we'll just say that there's going to be one variable in here, and that's called age. And the only real thing that this smart contract is going to do is it's going to store my age on the Ethereum network. I'm not sure why anyone would ever use this smart contract, but that's what it's going to do. So the first thing that we need is to create a variable to actually store that value. So there are different data types. I actually have a link right here. Let me pop it up. So there are different data types that you can use in Solidity. We're going to be kind of tackling these one by one, but a lot of them are pretty simple. Booleans, integers. We are going to be using a uint, which is pretty much just an unassigned integer or non-negative integer. However, there are some unique data types as well. So not just, your ints, your strings, so on and so forth, but this is a unique one where it's address. And of course, this is made to store an Ethereum address. And we're not going to be going over all of these. I just want to point out that if you do want to see the different data types, then you can type in Solidity data types and something like this is going to pop up. So that said, let's go ahead and create a variable for my age. And again, we're going to be using a uint, and that means a non-negative integer because I can't have a negative age. And we're just going to call it age. So end it with a semicolon. And again, whenever you're defining a variable, you put the data type and then the variable name ended with a semicolon. All right, so we have a variable. We have the ability to store my age in the smart contract. So now we actually have to write a function to set my age. So let me just go ahead and write this, and then we'll kind of talk through what it's doing. So you're going to call function. I'll just call this set age, and we're going to be passing in a uint, just call it x. And then I'll say public and age is equal to x. All right, so we'll get into this syntax in just a second, but just to talk about this logic real quick, all this function is doing is we're saying whenever we wanna set the age of Bucky, then what we're gonna do is we're gonna pass in a value, and then we're gonna take that value and set it equal to the age variable. Okay, so some things to point out here is one, whenever we are passing in arguments to our function, then we also need to specify the type of data that we are expecting. So this is similar to right here. Pretty much whenever you see a variable for the first time, it's going to need a data type right before it. Now, another thing that's interesting about this is this public keyword right here. So what does this mean? So functions in Solidity contracts can have different what is called visibility types. Now, public means that this function, it can be called basically by anyone. By anyone in the world, once this contract is deployed, they can call this function. If we had another function in here, which we're going to have in just a bit, then that function can call this function as well. Other contracts can call this function. So basically, anyone with an Ethereum account or even other contracts, this function is callable by, pretty wide open. Now, there is another keyword, and we're not going to be actually using this in this example, but just to point out, there's another keyword called private. And what this is essentially saying that this function, if deemed private, it's only callable by other functions in this contract. So that means that users couldn't call this function, other smart contracts couldn't call it. Private, again, it means that this function can be only called from another function within this contract. So let me go ahead and revert that back to public. And all right, so we have a function to set the age of Bucky. And now, before we kind of test this out, let me go ahead and create one more function. And all this is going to do is it's going to get the age, or pretty much return the value of age. And that's just because we want to be able to test it out later on, make sure that we have the right value set. So let's go ahead and do that right now. Function get age. Now, one thing to note is, unlike set age, where I want to set this variable equal to a new value, with get age, we're not going to be passing in any additional information because we're not going to be setting it or updating anything. We're basically just going to be reading this age variable to get the value. So one thing that we want to add is public because, this isn't like a private function. We don't need to hide anything from anyone else. We'll just say that anyone on the entire Ethereum network can see my age, no problem there. Now, another keyword that I want to introduce is view. So what is this view keyword? So a function declared as a view means that it doesn't modify any state. So for example, in this function right here, we were taking an age variable and pretty much updating the value of it. This would not be a good time to use view. In fact, this is kind of the opposite of when you should use it, because view means the opposite of that you are not modifying any state or any variables in your contract. So view kind of just means read only. And the last bit of info we need before we can start coding in the function body is this. Actually, let me kind of do it the reverse way. So what this function is going to do is it's going to return pretty much the value of age. So let's say 20, 30, 40, whatever it is. Now, whenever you create a function and it does return data, you need to specify what type of data is being returned. So this returns age, which is an unsigned integer. So in order to specify that, I'm just going to say returns and have parentheses there, uint. All right, so just reading this one more, we have a function, it's called getAge. It's a public function, means pretty much anyone can call it. It's read only, so it doesn't manipulate any data, and it's going to return an unsigned integer, and that is age. And that is pretty much it. Again, this is a very simple contract. I don't think it's something that anyone's ever going to use, but in terms of just getting something out there quick so we can figure out these other features we remix, I think it's looking all right. Now, before we take a look at the compiler, let's just go ahead and review why we even need to compile it at all. So we are going to be writing source code, and we just saw that. It was just, human readable Solidity code. Now, these nodes on the network, they actually don't run that source code. They need to run bytecode ones and zeros. So essentially, just a real quick overview, to compile, you are taking your source code, you are pretty much running it through a compiler and converting it to something called bytecode, ones and zeros. And then when you deploy your contract or pretty much upload it to the network, you're going to be uploading this bytecode just like that. And this is what the nodes are going to run. All right, so now let's hop back into Remix and take a look at how to do this. So on the left menu, you see that this right here, this is your file explorer, pretty much to get to your workspaces. Now right under here, you can see if you hover over it, it says Solidity Compiler. Let's go ahead and click that. So the first thing that you need to make sure of is that the compiler version matches this Pragma Solidity right here, pretty much just to make sure that your compiler and your source code are synced up. They're aware that it's the same version, so on and so forth. And of course, working with Solidity, a lot of this should be good by default. The one thing that I do want to point out is that if you're working on a small project, like just a few contracts, then it's probably nice to have this auto compile. And this just saves you from having to do it manually. Now, I will say that if you're working on a larger project with a lot of dependencies, then it's probably gonna kind of bog down your browser or your resources to have this auto compile feature. So typically you want to leave it on, but again, that's up to your best judgment. Now, I believe that's all we need to set for this. So now our code should be auto compiling. Now, after this, go ahead and hop down to this section right here. So deploy and run transactions. And let me zoom out just a bit. All right. Now, believe it or not, and I do want to bump this up a little bit since we're going to be seeing activity here in just a second. But anyways, believe it or not, Remix also includes a built-in mini Ethereum network. So you know that we talked about these different Ethereum networks. One was like the actual Ethereum network, the Ethereum mainnet it's called, and these other like Rinkeby, these were test and development networks. Now you can also just have a local network, or in other words, a mini virtual Ethereum network just running on your own local computer. So that's what this is right here with this JavaScript VM. So make sure you have JavaScript VM selected, and we can just work off this built-in Ethereum networks baked right into the Remix tool to make things a whole lot easier. Now, another cool thing about these networks is they also come with test accounts. So there are test accounts in here, as you can see, and each of them are loaded up with 100 ETH. Sure would be nice if that was real Ether, but look at me, dreaming away my days. All right, so just go ahead and keep the first one selected. Now under here, there are some settings for gas limit. We talked about that, what was it, in the last video maybe? And value, these two we really don't need to touch for this tutorial. Now this section right here is where we need to select our contract. And right now it says no compiled contracts. And that is because I actually set this to auto compile after the contract was already written. But if you want to compile this manually, then what you can do is hop back in your workspace, right click this and just hit compile. And then let's pop down here, see what this notification is. All right. SPDX license not provided. I have a typo or something. Whoa, what's going on here? And pretty sure that I had that too. All right, that was pretty strange. I believe I just pasted in the exact same source code and it seemed to work that time. But either way, that is how you manually compile, and now it looks like our auto compile process is working fine. So with that being said, let's hop back down to our deploy section, and you should have a contract in there that is now compiled. So how do we deploy this to our fake Ethereum network? And I'm sure you can guess this. Once you have everything selected, just go ahead and hit deploy. And if everything was successful, then you should see a success message right here in your terminal. Now, another thing is that if you scroll down a little bit, you will now have a new item under this deployed contract section. And this is essentially a reference to that contract, or in other words, an instance of Bucky. So the two functions that we had on the smart contract, let me minimize this a bit, were set age and get age. And that's what these two little buttons resemble right here. So it's pretty much just a very simple UI or user interface resembling your smart contract. Now, one thing to point out before we get to this is that if you scroll up, you are going to see now that how all of these accounts had 100 Ether, there's one, and this is the account that we used to deploy with, it has less than that. And this is essentially resembling the fact that whenever you deploy a contract to a network, it does require some amount of Ether. So this was just simulating that. So now let's go ahead and scroll back down. And okay, so we have our contract deployed, and there are two functions that we can call on it. One is set age, one is get age. Now for set age, let's go ahead and add some value in there right now. 20, click the button, and actually let me scroll down here. Okay, so I'm gonna click set age right here. And what this is gonna do is it's gonna send a transaction to the network, essentially calling set age with the value of 20. Now, whenever we did this, since it did require some update to the network, that is indeed also going to cost Ether. Now, if we just wanna read the value of that variable, then I'm sure you can guess what we're gonna do here. We can just call get age. And again, this is, of course, needs to interact with the network, but it returns the value of 20 right here. Remix isn't letting me highlight it, but there it is right here where my mouse is. And just to confirm that this is working, let's call set age again with 36 and get age 36. So there you go. A very simple way of deploying smart contracts and interacting with them from this Remix tool. Again, a lot of things built in. And to be honest, that's pretty much the basics of what we need to know about this tool for now. Some other quick things is, well, one, if you ever want to delete these, then you can just go ahead and hit this and you can delete those. And if you ever want to deploy again, just hit deploy and boom, there you go. And you can also deploy multiple ones at once. For example, if you want maybe a couple instances of it. And this is actually what I meant by there's not only one version of the smart contract living on the Ethereum network. You can deploy it multiple times and have different instances of it. So now I deployed it twice. So we got two versions of Bucky floating around. Maybe one has the age of 10 and one has the age of 20. And the last thing that I want to mention is that, let me go ahead and actually clean these up, is that whenever you are interacting with these smart contracts, Whenever you are using this JavaScript VM, again, this is basically a built-in browser network. So it's going to be a lot faster than interacting with the actual Ethereum network, even a development or test network. So just want to point out that if things are going really fast during development, and then when you try to, deploy it live, everything seems just so slow and it's bogging down. I just want to say that that's expected behavior. One of the benefits we get is a faster network with local development. So there you go, a very quick introduction to Remix, and I'm sure you're going to find this tool very helpful throughout your development career. So thank you for watching. Don't forget to subscribe, and I'll see y'all later.